All right, welcome. This is mathematics revision for grade 6, the next exam that they recently did. Question number 1. A photocopying machine produced that 5,106 copies of printed papers. Write the number of printed papers in symbols. So here we have 35,000. Then we have 106. So we write that 5,000 like that and 100 and then 6. Then we do through addition. So when you add them up, we get the correct answer. That is that 5,106. As simple as that. Question number 2. Mukami used the digits 3, 1, 5, 2, 6, 9 to form the largest and the smallest 6-digit numbers. What was the difference between the largest and the smallest number? The difference between the largest and smallest numbers formed. So here we have 3, 1, 5, 2, 6, 9, and we have the largest and smallest. So we write the largest number. The largest number means arrange the numbers from the largest to the smallest. That is 9, 6, 5, 3, 2, 1. Then smallest number means arrange the numbers or the digits from the smallest. That is 1, 2, 3, 5, 6, 9. So the difference, we have been told what was the difference between the largest and smallest numbers formed. So difference means take away. What is taking away? To take away means minus. So let us subtract. Furthermore, 1 minus 9, it is impossible. So we have to borrow a whole 10 from 2. So when you borrow a whole 10 here, it remains 1. And then we add it here, it becomes 11. 11 minus 9, it becomes 2. Then we continue. 1 minus 6 is impossible. So we borrow what? A whole 100. So a whole 100 we shall borrow from the 3. The remaining 2. Then we add that a whole here, it becomes 11. 11 minus 6 is 5. Then 2 minus 5, it is impossible, so we borrow again. The remaining 4, then we add 1 here. It becomes a new number formed, which is 12. 12 minus 5, it is 7. Then 4 minus 3, it is 1. And 6 minus 2, it is 4. And 9 minus 1 is 8. Therefore, the correct answer was 841,752. Question number 3. Tom planted 1,286 cabbages in rows and columns in his farm. The number of cabbages in the rows and columns were equal. How many cabbages were in each row? So let us have a square here to represent the farm that belongs to Tom, where the 1,296 cabbages were planted in equal rows and columns. So we ask ourselves, this is the area covered by the cabbages. So it means a certain number was multiplied by the same number to give us 1296. That means the concept here is square root. So which number was multiplied by itself to get 1,296? So this number is even. Let me use the factor tree method. The factor tree method. Remember, this is not prime factorization, but the factor tree method. So this number is even, so it can go by 2. When we divide 1296 by 2, we get 648. We divide again by 2 because the number is still even, we get 324. The number is still even, so we divide again by 2. We get 162. 162 is still even, so we divide by 2 to get what we call 81. When you get 81, remember 81 is a perfect square. We know its square root. It is 9 times 9. So dividing further, it gives me by 9, 1. Now, I have formed pairs. In every pair, I pick one of the digits. Or in other words, this is a pair of 2. This is another pair. Pair of which factor? Pair of 2. And you have another pair here, which is pair of 9. Now, the answer is 2 times 2 times 9, which is 36. So it means one of the side is 36 rows, 36 columns, and that was the answer. As simple as that. Question number 4. Question number 4. This is a grocer counted 245 oranges in a carton. She had 16 similar cartons containing oranges. How many oranges were packed in all the cartons? One box or one carton, 245. Another carton, 245. Another carton, 245. Another carton, 200. Hey, it means you are going to add all of them up to 16th carton. So you say, if one carton is 245 oranges, what is 16 cartons representing? Then we say it means cross multiply. 16 multiplied by 245. So this is 16 times 245, or 245 times 16. So 245 times 16, we use the long method. Let's write the multiples. 6, 12, 18, 24, 30, 36, 42, 48, and 54. Okay, don't mind. So the multiples of 6 here are 6, 12, 18, 24, 30, 36, 42, 48. So we ask ourselves, 6 times 5. What is 6 times 5? It is 30. So we write 0, we carry 3. Write it at the top there. So 6 times 4 is 24. Plus 3, 27. We write 7, we carry 2. 6 times 2 is 12. Plus 2, 14. You write it there because that is the last digit in the factor. Now we come to this digit will be dropped in 0 because we don't write there when we are aligning the digits unless you put 0 there. So 1 times 5 is 5, and 1 times 4 is 4, and 1 times 2 is 2. Then we do through addition, and that becomes 3,920 was the total oranges in the 16 cartons. Question number 5. Question number 5. Question number 5 says, a forester donated 3,918 tree seedlings to 23 schools. By rounding off each number to the nearest 10, estimate the number of tree seedlings donated to each school. Here we have things to consider. We are being told by rounding off each number to the nearest 10. Estimate the number of tree seedlings donated to each school. Each means 1. So working out, here we have 3,918, that is the dividend, and 23 is the divisor. But first, let me rule here. We say rounding off to the nearest 10. We have what we call strong digit and weak digit. 3,918, we have strong digits are 5, 6, 7, 8, 9. They give an addition of 1 to the left-hand side. So this one is 8. 8 is a strong digit, as you can see. So it will give an addition of 1 to the nearest 10. So now when you are writing the new number formed, it will be, it becomes 0 for 8 and 2 after adding 1 plus 1, and then the other digits remain. So that 9, that is 3,920 will be the new dividend. Rounding off to the nearest 10, let us talk about 23. So here we have what we call weak digits. Weak digits are 0, 1, 2, 3, 4. They do not give an addition of 1. What do? Instead, they die. They become 0. So they affect the number negatively. The number becomes smaller than it was. So 3 cancels to 0 and 2 remains. So the number has now been baptized to 20. So our new dividend is shared by new divisor. So 3,920 being shared to 20. That means 3,920 divided by 20. So let us write the multiples of 20. As you can see, 20 times 1 is 20, 20 times 2 is 40, 20 times 3 is 60, 20 times 4 is 80, 20 times 5 is 100, 20 times 6 is 120, 20 times 7 is 140, 20 times 8 is 160, and 20 times 9 is 180. So look at, can 20 really divide 3? No. Can 20 really get into that 9? Yes. How many times? Look at the number which is near that 9. That is 20. So it is 20 times 1 to get 20. We subtract. When you subtract, you get 9. That is 19. Drop 2. Remember, when you drop, it means you are forming a new dividend, or you are forming a new number to be divided again. When you drop, you must divide. Never drop and say, this is remainder. No. So 192 being shared by 20. Look there. Which multiple is near 192? Definitely it is 180. Can you see it actually? Yeah, 180. So it means 20 times 9 gives us 180. So now share. That means now subtract. Take away. So when you take away, you get 12. 12. What do we do? Look at the 0 up there. So you must drop it. When you drop, you must divide because you are forming a new number. Look at 120. Can you see 120? Yeah, 20 is there. So 120 is 20 times 6 gives us 120. So the sum is over. So when you subtract, you get nil. So the answer is 196. And that is the correct answer. Question number 6. Question number 6. Ongeri cut a piece of sugarcane from the farm. He chopped the top part and remained with 5/6. He gave his friend Kimutai 2/3 of the piece of sugarcane. What fraction? It is written what fraction, but this is what fraction of the piece of sugarcane remained? Working out. So to give away is to subtract, isn't it? So fraction of the sugarcane. Take away the fraction of sugarcane he gave to Kimutai. So that means the fraction of the sugarcane he had after chopping the top part, it was 5/6 minus 2/3, the part that was given to Kimutai. So that is the concept. All right. So 5 over 6 taking away 2 over 3. Look for LCM. We shall say, look for LCM, divide by the denominator, and multiply by the numerator. Or you can as well rename the fractions using a common denominator. In this case, I want to use a common denominator where 3 changes to 6. So 5 over 6 minus 2 over 3. I write the multiples of 3. 3, 6, 9, 12. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. So 3 by 2 is 6. So 3 times 2. To make 3 become 6, I must multiply by 2. What I multiply by the denominator also happens to the numerator. So I say 2 times 2 will be 4. So I formed a new fraction, which is 4 over 6. I have baptized two thirds to become 4 over 6. So I say 5 over 6 minus 4 over 6. The denominator does not change. We do not subtract the denominators. We only subtract the numerators. So 5 minus 4 is ulifunzo. This is 1. And then we keep the denominator. So it is 1 over 6, as you can see. All right. The correct answer. Now, question number 7 is the last question in our session. So, Adhiambo obtained 24 out of 30 marks in your mathematics assessment. Hey, huyu alipita. What was the score as percentage? So this is conversion, converting fractions into percentages. So 24 out of 30. If he could have scored 30 over 30, we would say he has 100%. So 30 equals to 100%. What about 24? Will be equal to what percentage? So you say 24 times 100. Then the 30 comes down as divisor. So it will be 24 over 30. 24 over 30 times 100. 24 over 30 times 100. So that is 24 times 100, which is 2,400 divided by that. So use the long division to be comfortable. So this is 2,400 divided by 30. That is 8 times, because you know 3, multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24. So it is 8 times 8. 30 times 8 is 240. Then you take away. It becomes nil. Then you drop. We said when you drop, you must divide. Never drop and you say that is remainder. No. So when you drop, a smaller number is divided by a bigger number 0 times because of 0. So it is over. So 0 times 30 is 0. Then you take away, useless. So the correct answer here is 80%. 80%. It was as simple as that. Thank you for watching and following.